Hello, my math class. This is our last video for the first week doing 2D and 3D shapes. Today's focus is three-dimensional shapes. So this would be the page you're on. It's the last page in the packet. And we are going to be working with shapes that have now an added dimension. That's why they have 3 dimensions, because instead of like a flat shape, like a piece of paper, if I have a blank piece of paper, here we go, like a piece of paper, the shape has only 2. It goes this way and this way. However, when we add that 3rd dimension, we now have this way, and go this way. So if you look on your paper, you'll notice that the picture has dotted lines on the shapes. Those dotted lines represent that backside that you can't see when you're looking at a 3D shape. Okay, so our first 3D shape is a cube, and I apologize for any extra noise you might get. I'm trying to keep my kiddo happy. Our cube has a couple of different things than a flat shape has. So flat shapes, we were looking at sides and vertices. Well, we still have vertices, so we still have the points, but now we have the word edges. And an edge is this flat part where 2 of these come together. This flat side that we look at, that is called the face. So if you'll notice along the top of your paper, you have those 3 words: faces, edges, and vertices. Not in that order, but there we go. So what you're going to do is we are going to be counting up those different things on our different shapes today, okay? So I'm going to start with my cube, and I used this lovely dice because it's already numbered for me. How awesome is that? So let's talk about edges first. I'm going to look at this number 1 side. If I look at the edges, these are our flat sides that are connected together. I can see 4 edges as the outline of my square, okay? That is the 4 edges here. Now, I also have an edge that comes back from each one of these vertices, so that is another 4. So I have the 4 that are on the front, the 4 around the sides, and I turn the block around, I have the 4 on the back side. So that's 3 sets of 4, or 4 plus 4 plus 4, or 4 times 3, and all of those add up to 12. So the number of edges that our cube has is 12. So we'd write that down under edges. The next one is vertices. These are the points, the corners where they come together. Okay, and if we look, we have the corners on the front of the square, 1, 2, 3, 4. And we have corners on the back of the square, 1, 2, 3, 4. Okay, so you have to count both sides of those for our vertices. So we have 8 vertices on our cube, and the faces are the flat parts, okay, so the ones with the numbers. And if you know how many sides a dice has, we know how many faces are on a cube. So we can look, 1, 2, 3, like I said, they're handy in numbers, 4, and 5, and 6. Now, they have theirs numbered weird. I like to count my faces. I count the sides, and then the front and the back. So I know that there is a flat face for each one of these sides. So 1, 2, 3, 4, and then the front 5, and the back 6. Okay, so if we look for our cube, I don't want to show you too much because I had it all filled out. Our cube has 12 edges, 8 vertices, and 6 faces. Okay, so for the next one, our cone, think of a party hat or an ice cream cone. There are how many edges, okay? How many places where they come together, where the flat bottom part meets the top hat part. There's my picture, without giving too much away. We have 1 edge, okay? And now, because there's only 1 flat part, there's only there's 1 pointy part, 1 vertice. I'm sorry, we're gonna have to restart this in a minute. Okay, so let's look at a cone example. The very tip of this pen is shaped like a cone. So we have the point, that's the vertice. The part where they come together, that's the edge. I know it's a little blurry. And then if this was cut off, so I could set it down instead of connected to a pen, the flat part would be the edge. So there is 1 vertice, 1 edge, and 1 face. Sorry, I meant to say face. There we go, there's our cone. Okay. The next one on the page is a cylinder, and I have found that there are a lot of cylinders around my house. I found a tube of chapstick. I found my water bottle. Very great example. A glue stick that is also a cylinder. So cylinders are all over, and they have a couple of different ones. Now because they have this rounded edge, just like with our cone, this does not count as a face because it is curved. Faces are flat. So on this one, we have a flat face and a flat face. So this one has two faces. It also has two places where they combine, or two edges. But this has no points, so this has 0 vertices. Okay, so for our cylinder, we have 2 edges, 0 vertices, and 2 faces. Okay. The last one that we will do together is the sphere. And I don't know what happened to mine. Anyways, a sphere is just what it looks like. It's a ball. So you can think of a toy ball, you can think of a globe, whatever ball you want to think of. That is a sphere. Now, if you think about that, there are no flat edges, no points where they come together, no vertices, and no flat faces. So across the board we have 0, 0, 0 for our sphere. Okay. The last 3 are pyramids, triangular prisms, and rectangular prisms. And the only way that they are different is in their shape. But they have flat edges, they have flat sides, and they have lots of good points. So I want you to find some of these around your house, around your neighborhood, wherever you can look. And I want you to count up your edges, vertices, and faces. That's the other one. Edges, vertices, and faces. And see what you can find, my friends. And then fill out your paper. We'll pause this video, fill out your paper, and then come back because I'm going to show you the full page all filled out correctly so you can see if you did it right. Okay, so right now, pause the video. I mean it, pause it. Okay, did you pause it? Good go. Okay, hopefully your paper is all filled out. Here is what it should look like if you are all done. Okay, so I'm just going to hold that there for just a quick second so you can look. Oh, it goes backwards to you. I don't know. I'm trying to read them. And I'm reading them backwards. Hopefully it's the right way for you. Okay, so there you go. That's what they should look like. Hopefully you guys found some in real life. Hopefully you were able to find them easily and count up all those vertices, edges, and faces.